Hi, welcome to Darth Dragon Does Math. Um, it's currently Christmas break, but it won't be when you're watching this. So, welcome back, guys. All right, so let's do some direct proportion. So, before I begin, let's go ahead and define what direct proportion means. Direct proportion means it is a relationship between two quantities in which both quantities increase and decrease by the same factor. What I mean by that is you will have two things, two quantities that go up or down by the same rate over and over and over again. Now, an example of this, one of the best examples of this, is anything that is a unit price. Basically, miles per gallon, miles per hour. If you go to the store, you'll notice costs per pound. Apples are $1 per pound or whatever. You buy gas at the pump at the same price. That's a unit price. As the more gas you pay, or the more gas that you pump, the more price you pay. So it's two quantities. For example, the gas and the pump and the price. One quantity is obviously the gas, and one is the price. As the price will stay the same, but the amount you pay, really. The gas, if you buy more gas, you pay more money. And the price of gas is the factor at which it goes up. That right there is the constant of proportionality. Whatever the factor is, or the rate is at which those two quantities are going up or down, is the constant of proportionality. Now let's do a couple examples showing you a little closer idea of what I mean. A pet store owner uses a table to decide how many of a certain type of fish to put in an aquarium. To tell whether the number of fish F is directly proportional to the volume of water in the tank. If so, give the constant of proportionality and tell what it represents in the situation. And then write a direct proportion equation. So what's going on here is a guy has a little table and he says, okay, this aquarium is so big, this is how many fish you can fit in there. And basically what we're deciding is whether or not that's proportional. Is the size, the water per gallon, proportional to the amount of fish you put into the aquarium. So to do this, we have to decide as it goes up, does it go up over here the same amount? Now, the easiest way to do this is actually just look at each one of these individually, and we divide. We say, okay, so we take whatever is on the bottom, 6, and we divide it by what was on the top. 6 divided by 4. 6 divided by 4 is 3 halves. And we'll do it again. We'll say 15 divided by 10. 15 divided by 10 is also 3 halves. And the way I'm finding that is I'm just simplifying. I'm dividing this one, dividing both of these by 2. Another thing you could have done is you could literally divide 6 by 4 and you would get 1.5. Divide 15 by 10, that's equal to 1.5. And then finally 30 over 20. I will simplify these by 10 each. 30 divided by 10 is 3. 20 divided by 10 is 2. And you'll notice I got 3 halves, 3 halves, 3 halves. That means that this is directly proportional. If you're getting the same thing every time, it's directly proportional. And what we call the constant of proportionality is actually K. I didn't say that up here, but K is equal to 3 halves. Okay? So K is equal to 3 halves, and it represents the amount of fish per gallon of water in a tank. The amount of fish per gallon of water. The number of fish per gallon of water. Okay, so whatever's here, this is top. We usually say top, or this comes first per this. And we'll get into more about why later. Really, I don't want to throw too much information at you at once, but the reason fish comes first is it is dependent on the amount of water in there. So basically, you put the water in first. You don't put the fish in first. The amount of water that you put in determines the fish can fit in. Sorry about that. And then we want to write a direct proportional equation. Now these are very simple. We take whatever the bottom was again, F, and we set it equal to whatever K was, so 3/2, and then whatever the top. F is equal to 3/2 G. Now you won't, this is very simple, but it takes a couple steps. So if you don't get it by this time, the one on this, the second question here, please stop, take a second, review the video. Okay, so this table shows the distance traveled by a snail very fast. D centimeters after T hours. Tell whether D is directly proportional to T. If so, give the constant of proportionality and tell what it represents in the situation. Then write a direct proportion equation. So in 1 hour, the snail traveled 9 centimeters. And 2 hours it did 18 and 321. So again, we take this, we'll say 9 divided by 1. Well, that's obviously 9. Then we'll do 18 divided by 2, and that's 9. And then we'll do 21 divided by 3, which is actually just 7. So since 7 is not the same as the other two, this is not directly proportional. And you don't have to do anything else because it's not directly proportional. Now let's imagine if it was 9, okay? So it is 7, but if it were 9, then that would represent the distance traveled per hour. So basically centimeters per hour of a snail. And your equation would be D is equal to 9T. Now this is right there, that is an if, but it was directly proportional, but it's not, so you don't have to do that. So do the same thing here, decide whether or not it's directly proportional, figure out what the proportion is, K is equal to whatever, write an equation. On the back, tell whether the equation represents a direct proportion. If so, identify the constant of proportionality. So the way we do this, if we're trying to decide whether or not something's directly proportional, is we get y alone. That's it, or whatever, one of the two variables alone, because it's not always y and x. So this is 1/2 times y. So I'm going to multiply both sides of this equation by 2/1. Okay, so 1/2 times 2 is 1, so that's y. And this is 3 times 2, that's 6. X stays. Y is equal to 6x. Now we're looking for something that is y is equal to kx. Remember, k is the direct constant of proportionality. So we're looking for something that looks like this, nothing else. That looks like this, where in this case 6 is equal to k. So it is a direct proportion where k is equal to 6. This one, get y alone. Let's add 2 to both sides. And I get y is equal to 5x plus 2. Now this does not look like that because I've got this plus 2 here. That screws everything up. So this is not directly proportional. So this one, y is directly proportional to x, and y equals 3 when x equals 9. Find the constant of proportionality, then write a direct proportion equation. So again, we're going to use this y is equal to kx. Okay, the way we do this is we say, okay, when y is equal to 3, y is equal to 3 when x is equal to 9. So basically we're writing this equation, plugging in 3 for y and 9 for x. And I know that looks funny, so feel free to flip that around and write it like that, if it helps at all. I want to get k alone to solve for k, so I'm going to divide by 9. So I'm going to get k is equal to 3/9, if these cancel out, or 1/3, if I simplify that. So k is equal to 1/3. So to write a direct proportional equation, we're going to say y is equal to 1/3 of x. And let's talk about why this makes sense. If I were to plug back in x equals 9, so we'd say y is equal to 1/3 times 9, does y equal 3? So 9 divided by 3 is 3. It does. It checks out. So that's the quick way to decide whether or not you did it right. Now, if you get a word problem and ask you to find direct proportionality, this is back to the unit rate. Remember, unit means 1. What we're trying to find is if Jose drives 75 miles on 5 gallons of gas, and the amount of gas he uses is directly proportional to the miles he can drive, find the constant of proportionality of the cars in miles per gallon, and write a direct proportional equation. So a lot of words for something very simple. You're trying to find, if he goes 75 miles in 5 gallons, how many miles can he drive on 1 gallon? That's all you're trying to do. Now the easiest way to do that is just divide 75 divided by 5. Now I know that is 15. So in this case, that is the unit rate, 15 miles per gallon. 15 miles per gallon is also the constant of proportionality. So in this case, you'd say k is equal to 15 miles per gallon. And you don't have to write all that out on mpg. Yeah, that's what car makers do. 15 mpg. That looks terrible. K is equal to 15 mpg. All right. Now, and to finally write a direct proportional equation, you would say, let's do miles is equal to 15 G. Now what this means is that for every gallon I have, I can drive 15 miles. If I have 2 gallons, I can drive 30 miles. If I have 5 gallons, I can drive 75 miles, and so forth. Okay, so this is your equation. These are all very similar to the ones we just did. If you don't understand, if you're worried about how to do them, don't know where to start, please review that right there. But I expect this done tomorrow. Have a nice day. Enjoy doing some math.